All right, let's jump right in. We all think of time as, well, a line, right? It goes from the past through the present and into the future. Simple. But what if that's just one tiny part of a much bigger picture? Today, we're diving into a really fascinating and, yeah, pretty controversial idea from the very edge of physics, the theory of three-dimensional time.
You know that old saying, time is like a river? Okay, for a minute, just throw that idea out. Instead of a single current pulling you along, I want you to picture an entire ocean. Sure, you can still move forward, but what if you could also go up, down, left, or right? This one question, if you really think about it, messes with everything we assume about reality.
I absolutely love this analogy someone posted on Reddit. It takes this super abstract concept and makes it feel, well, almost like you could grasp it. They call it temporal surfing. So moving forward, that's just your normal Tuesday, the regular flow of time. But moving up or down could be like shifting into a different quantum state. And moving left or right, whoa, that could drop you into a parallel universe. It's a wild thought, and it's what kicked off a huge scientific debate.
Okay, so how do you get from a cool thought experiment on the internet to an actual scientific theory? Let's break down what this actually means. So here's the core of it. We're all used to the three dimensions of space, right? Length, width, depth, up, down, left, right, forward, back. Easy. This theory just asks, hey, what if time works the same way? Now, stepping sideways in time isn't like hopping in a DeLorean. It's more like exploring a different what if, a different possible outcome of the exact same moment. It's a subtle idea, but it's a profound one.
And this is a great way to picture how scientists try to model it. You see that line, T0? That's our normal, everyday clock time, just ticking along. But then, sticking out from it, you have T1 and T2, two extra dimensions of time. And here's the really mind-bending part. In this model, all that super weird quantum stuff, like a particle being in two places at once, maybe that's just the particle zipping around in these other time dimensions while we're stuck moving along our single track.
Now, this idea of extra time dimensions had been kind of kicking around in physics for a while. But then, one paper dropped that claimed it had the actual math to make it all work. And believe me, this is where our story gets really good.
This paper was published by a geophysicist named Günter Klettishka. And you might have just caught that. A geophysicist, not a particle physicist. You are going to want to hang on to that little detail, because the claims he was making in this paper were just astounding.
I mean, Klettishka wasn't just suggesting a little tweak to physics here. He was basically saying we should tear up the textbooks and start over. In his mind, time isn't just part of the universe, it is the universe. It's the canvas that everything else, including space, is painted on. That is about as bold a claim as you can possibly make.
And it didn't just stop with big, poetic ideas. The paper claimed it had the receipts, that it could use this framework to solve some of the deepest mysteries in all of physics.
And look, we are not talking about small potatoes here. Every single one of these points is a holy grail for physicists. Unifying quantum mechanics and gravity, that's the dream. Predicting the exact masses of particles from scratch, nobody's ever done that. And then, to top it all off, it even predicted new particles we could actually go look for. If this was true, it wasn't just a big deal. It was a Nobel Prize-level rewrite-everything kind of discovery.
But before you can rewrite the textbooks, your theory has to survive its first and maybe most brutal test, the collective critical eye of the internet.
And this is where our Reddit friend, Dr. Clowncar, the temporal surfer, comes back into the picture. He finds his paper, gets super excited, and posts it on a physics forum with a simple question, "Hey guys, is this for real?" The response he got was swift, and it was absolutely devastating.
The very first domino to fall was that massive claim about predicting particle masses. The experts on Reddit took one look at the math and immediately saw the problem. The paper wasn't predicting anything. It was doing something called a post-fit.
So what does that mean? Well, it turns out the formula in the paper had a bunch of knobs you could turn, these free parameters. And the Redditors figured out that the author had simply twisted those knobs until the formula's answer perfectly matched the particle masses we already knew. The analogy one person used is perfect. It's like shooting an arrow into a wall, then walking up and drawing the bullseye around it. It looks impressive, but it's not a prediction.
But wait, you might be thinking, it was peer-reviewed, wasn't it? And yeah, it was published. But here's the thing, not all scientific journals are created equal. The community pointed out this one was pretty new and what's known as low impact, which means the peer review process probably just wasn't as tough as it is at the top-tier journals.
As the community kept digging into the math, the language got a lot harsher. One commenter, after breaking it all down, just came right out and said it. In their opinion, passing off a post-fit as a genuine prediction, that crosses a major line. They didn't call it a mistake. They called it scientific fraud.
And that single word, posted by another user in response to the takedown, just perfectly summed it all up. The theory, at least as it was presented in this paper, was completely and totally dismantled.
So, is that the end of it? A crazy theory gets debunked on the internet, story over? Not quite. Because the failure of this one paper doesn't mean the entire idea is dead. It's actually part of a much bigger scientific hunt.
This is the key question, right? Just because one paper got the math completely wrong, does that mean the whole concept of extra time dimensions is just junk science?
And the answer is a definite no. In fact, you've got serious researchers at places like the University of Warsaw exploring very similar ideas. Their work involves thinking about what the universe would look like from a faster-than-light perspective. And guess what? Their math also leads them to a framework with 3 dimensions of time. And the goals of this legitimate research are just as ambitious. They're trying to answer the biggest why questions in physics. Why is the quantum world so bizarre? How does the Higgs boson actually give things mass? These mind-bending theories about extra dimensions of time, they aren't just for fun. They are serious tools scientists are using to try and build a complete theory of everything.
And that really brings us to the main takeaway here. The story of this one paper isn't really about a failure. It's a fantastic real-world example of science working exactly the way it's supposed to. An idea gets proposed, it gets shared, it gets scrutinized, its flaws are exposed, and the community corrects the record. It might look messy from the outside, but that's literally how progress is made.
So we're left with this really tantalizing thought. The journey to understand reality is all about proposing ideas, testing them, and yeah, a lot of failing. But every single attempt, even a misstep like this one, helps us refine the map. It just leaves you wondering, what else is out there, hiding right in front of us, just waiting for the right theory and the right evidence to completely change our reality?